Hi everyone. So today we will discuss about alkenes and alkynes and we will see how we can name these compounds. But straightly going through the IUPAC naming of alkenes and alkynes, so I want to discuss something about their structure and what kind of bonding and the general formula this class has in the organic chemistry. So alkenes, these are basically alkenes and alkynes are the examples of unsaturated hydrocarbons. They are grouped under the hydrocarbon class because they are only made of the carbon and hydrogen. There is no other um, atom in it. So we categorize these one as the hydrocarbons. Though they are the substituted alkene based and alkyne based halides and other compounds are there. But if you just generally you are categorizing on the basis of the functionalities that either we are just describing that this is a double bond, this is a triple bond, so they are categorized as the hydrocarbon. So hydrocarbons contain alkanes, which we already have discussed. So you can just check out my lecture on the alkanes, their naming and their structures and their some of the reactions, which is available on my YouTube channel. And the other one is that the aromatic compounds, and that we will discuss later. But aromatic or the arenes are also grouped under the hydrocarbons, and they are again the unsaturated hydrocarbons because they have the multiple double bonds. So right now in this lecture, we are only focusing on the alkenes and alkynes. So alkene as a structure, they are unsaturated hydrocarbons. Their hybridization is sp2 because there is one s orbital and there are two p orbitals which are participating and the hybridization, and they come out with the three sp2 hybridized orbitals. There is the carbon-carbon double bond, and if there is only the one double bond and this is not in a ring structure, this is not the closed structure, or they are not in a cyclic structure, so then the general formula for this class is CnH2n. This is basically giving you the ratio of the hydrogen and carbon in case of the alkene compound when it is only having the one double bond. So don't confuse it and don't try to fit that formula on the compound or the kind of alkenes which have the multiple double bonds or which are the cyclic or in the ring form. So that won't fit into these compounds. So this is only applicable for the alkenes which have only one double bond, and this is in non-cyclic or in the open chain or aliphatic form, right? So now, if you just look at its open structure, this is its open structure. So here you can see this is a carbon, there is a carbon, and this is each carbon is attached with the two hydrogens. Now how this is different from the alkene? So in alkene we had discussed that the general formula is CnH2n plus 2 because there each carbon is bonded with the maximum number of hydrogen, as we already have pointed out that this is the hydrocarbon. So there is no other atom other than the carbon and the hydrogen. So now if you just look at this, that there are the two bonds between the carbon and carbon. So there is one sigma, which is the first single bond. This is between the carbon and carbon. This is the sigma bond. And the other one is the pi bond. So this is the simplest alkene example, and this is ethylene and alkene, and this is its common name. So now this is the ball and stick model of this compound, and if you just see this compound from a side view, so that looks like this one in the spatial rearrangement or in a 3D structure, that there is the carbon which is mentioned with the black ball, and each hydrogen has mentioned with the white small balls. So there is a double bond between the carbon and carbon. So if we just compare the alkynes with alkenes, So alkynes has the triple bond between the two carbons. So there is one sigma and there are two pi bonds. This is the sp hybridization, and the static number of sp hybridization is 2, because with the mixing of one s orbital and one p orbital, we uh, we get that two sp hybridized orbital. So this is the formation and how they make the bond in the alkyne. This is through the sp hybridization. So if a molecule has the carbon-carbon triple bond and there is only one triple bond, so you just have to focus on it that this is a triple bond, not a double bond. There is a type of mistake. So if it is having only one triple bond and no ring, so then the general formula for this one is the CnH2n minus 2. What does it mean? Because in alkenes we have seen that there is the two hydrogens less than the alkenes, and then there is the further reduction or the deficiency of the hydrogen from the alkenes when we get another third bond between the carbon and carbon, because definitely there was the one hydrogen attached to this carbon previously, and when they both are making the bond with each other, so definitely that hydrogen and hydrogen bond will be removed. So it means there are the further two hydrogens will be reduced or deficient from the alkene structure. So that is again applicable only for the open chain structures and which has only the one triple bond. Now we will go for the naming of the alkenes and alkynes. So if you have watched the alkane video lecture, so you know and you are familiar with the IUPAC rules, that what we have to follow for naming these compounds. So you can just watch that lecture as a reference again if you just want to refresh the IUPAC rules. So these are almost the same one. The only change is that now the functionality in alkenes and alkynes is the double and the triple bond respectively. So there will be the change in their suffix. So we will go for it, that for the alkene, in case of the alkenes, there is the double bond, which is present as a functional group, which give the distinct chemical character to that compounds in comparison to the alkenes. So now we will use the ene is a suffix we will use for naming that class if there is a molecule with a double bond. So we can see the example. And the one thing you have to keep in your mind that you have to select the longest chain which contain the double bond. So if there is any possibility that you can choose a chain and longest chain which is not having the double bond, so that is not the correct approach, because we can't ignore the functional group in a molecule. So either if there is a one or two carbon less than the longest chain, but it includes the double bonded carbon, so then we will prefer to choose that longest chain. So here there is an example that this is the 6 carbon chain. There is the 1, 2, 3, 4, 5, 6, and this is another molecule where there is the substitution at the 4th carbon, right? So we will start numbering the chain or the longest chain from the side where there is the double bond. If it is at the terminal or at the end of the compound, that's fine. But in case if this is at the second and the third carbon, even then you will pick that side where you can assign the lowest number to that double bond. So if there is any substitution, just like this methyl one, so its pattern to name is the same as alkane. And I have told you that in naming of the organic compounds, that has the 3 parts. One is the prefix, the second is the parent, and the third one is a suffix. So prefix is for mentioning the position and the name of the substitutions. Now the parent is the name of the parent chain, that what is the longest chain. Either that is the 3 carbon, then we will use the parent prop uh, for that, for naming that one. If that is the 5 member, then we will use the pentane, and depending on that we have to adjust its suffix with the class name. So now in that scenario, uh, this is the example, right? This is the open structure and this is the line structure. So in a line structure, we don't mention the hydrogens. So this is understood that for each carbon, there will be the maximum hydrogens which can make the bond uh, um, with that hydrogens. So now we will start numbering from the side where we can assign the lowest number to the double bonded carbons, right? So this is between the carbon 1 and carbon 2. So to mention the double and the triple position, we always start and write the lowest number. We start from the carbon, which is the first carbon which is involved in the double bonding. So here, for the 6 carbon chain, the parent name is the hex. Now we know there is a double bond, so this belongs to the alkene class. And for the alkene, we will use ene as a suffix to mention that we get the clear idea that this is a compound which has a double bond, and that belongs to the alkene class of organic compound. So now this is the 6 member carbon hex in ene for the double bonding, for representing that this is the alkene. And now we will put the 1 position here, and this 1 position is mentioning that this double bond is not somewhere at the middle. So this is between the carbon 1 and carbon 2. Now the second example, so I have drawn its line structure. This is its open structure. So you can see again, if we'll count the longest chain, 1, 2, 3, 4, 5, and 6, right? If I go through this side, 1, 2, 3, 4, and 5, so we have to choose a continuous longest chain, right? If I choose this one, so then that will be the 5 member chain. And if I go to this side, so this is a 6 member chain. And in both cases, we are including that doubly bonded side. So it means we will prefer this longest chain because this is the higher in carbon number, and that include the carbon-carbon double bond. So here, the first thing is that what is a parent chain name? So this is 6 member. Again, we will use the hex. This is the alkene class. So ene. Now this is the double bond between the carbon 1 and carbon 2. So here we will use numeral 1, right? Now we have to work on the prefix. So for the prefix, and this is the compound which is different than the previous, which was the 1-hexene. So there is another methyl group which is attached. So definitely that is another compound. So we have to name this compound according to that structure. So now this is a methyl, and that is attached at the 4th carbon of that 6-membered chain. So this is the 4 for mentioning that this is a 4th carbon where the methyl group is attached, and the methyl is a substitution. So we will write it meth is for the 1 carbon group, right? So this is a CH3, and YL is for mentioning that this is as a substitution, and we use a YL for that. Now there is a challenging example. So just to elaborate that how, if you are just confused that what kind of chain, longest chain you have to select. So here, if you just look at this one, if I go through this 1, 2, 3, 4, 5, 6, right? This is a 6-member longest chain. And if I go through this 1, 2, 3, 4, 5, so this is the 5-member longest chain. But what is the difference between 2, 1? Though in this scenario, I am getting the higher number carbon chain. But what is wrong with that one is that this doesn't include that doubly bonded carbon here. So the functionality, which is the major functionality in that molecule, that is the double bonding. So we have to select that longest chain on which we can categorize that molecule in a certain class of organic compound. So that is that we include that carbon in the longest chain. So that is the side 1, 2, 3, 4, 5. And if you just look at its open structure, so again, that will be easier for you, that we are picking this longest chain and this methyl, which is here, right? So this methyl, which is at the fourth carbon, and this ethyl group, because there is this CH3 and this is a CH2 which is attached there, CH2 and CH3, which is another substitution. So how we will name that, just do in your mind, and we can check with our answer that either you get that you get the correct name in your mind. So uh, for by practicing or by applying all the rules we have discussed so far, so that should be the pantene, right? So this is the pantene, and it's one position. This is the double bond between the carbon 1 and carbon 2. So we will write the 1 pantene. But what about the substitution? So there is the ethyl or ethyl substitution at the carbon 2, and there is the methyl substitution at the carbon 4. So another rule for naming the substitution is that when there are more than one substitutions and they are different, so we will select these and we will write them on the basis of their alphabetic order. So E and M. So we will write firstly the ethyl, and then we will write the methyl one, right? So this will be 2 ethyl, 4 methyl, 1 pantene. So now we can check that one. 2 ethyl, 4 methyl, 1 pantene. So that is the correct IUPAC name of that molecule. Now, some of the common substitution names, which if you just get grip on that, so that it's easier for you. You can use the IUPAC name also, but their common name are also well accepted and they are IUPAC approved. So you can write in that way too. So you should know that what is the vinyl, what is the methylene, what is the allyl. So you should know that what is the IUPAC name and how their structures look like. So methylene or methylene is basically a CH2 doubly bonded, right? So it means that this CH2 is attached to some of the alkyl group where, and most probably this is in a cyclic form, right? Or in a ring form. So where this is attached, and this methylene with the double bonding, we will mention this in a name. So here IUPAC prefix we will use for it is the methylidine, and common name is methylene, right? So how we will name that one? So here this is a cyclic structure. So for cyclic structure we use the prefix cyclo, and this is the 5-membered ring, so we will use the pent, right? And now this 5-membered ring is basically not having any double or triple bond. This double bond is outer than this ring structure, right? So it means this is the alkane. So we will write this cyclopentane, but here this is a CH2 as a substitution. So if we are writing it in an IUPAC way, so we will write the methylidine cyclopentane, and we can use its common name also. So this is the methylene cyclopentane. Some pronounce it methylene cyclopentane, so the both are fine. So another one is the when this is the CH2 doubly bonded CH, and this carbon is attached with another group, right? So let's say if we are keeping that side same, which is our parent chain, and how we can name this substituted alkene group. So here this is the 2-propenyl cyclopentane, and for this one, this is the ethynyl cyclopentane, and vinyl is its common name. So you may heard about, and you may see some of the chemical bottles, they usually write this name for these one, because this is quite familiar and very commonly used rather than their IUPAC name. So this is the vinyl cyclopentane. So could be the question that why we are choosing, not choosing this one, and why can't we write this as a cyclopentyl, and then we can write this is a ethene one. So definitely in that scenario, this longest chain is the carbon, and this is a cyclic structure. This is a separate entity, and there is the double bond. So these are some of the common substitutions which we treat it as the substitution. So we can write it as ethynyl cyclopentane and 2-propenyl cyclopentane and methylidine cyclopentane, and their common names I have told you that this is a methylene cyclopentane, vinyl cyclopentane, and allyl cyclopentane. Now, how we can name and what is the difference when we are naming the alkynes? So this is almost the same as the alkenes. The only thing which is different is that now we have the structures with the triple bond, where there is a 1 sigma and there are 2 pi bonds. And the suffix we will use is the Y, but we will number in the same pattern as we did with the alkenes one. So you have to pick the longest chain which includes the triple bond, right? So here this is the 1, 2, 3, 4. You can either name in that way 1, 2, 3, 4 because their both sides are the equivalent one. So other methyl group will be treated as a substitution. Now the second example is this is the 1, 2, 3, 4, 5, 6, 7, or either you can go to this side 6, 7, or either you can go to this side 6, 7, right? So the rest of the 2 methyl will be treated as a substitution. So the question is that from which side we will start the numbering. Let's say if I start numbering this side 1, 2, 3, 4, then I'm assigning the higher number to the triple bond, and I have to pick that side to number where I could assign the lowest number to the functional group and lowest number to the substitution. So when we have to compare the substitution versus the functional group, so then the functional group has a preference. So we have to give the preference to that functional group that we decide, and we start from the side where there is the lowest number to the functional group, then to the substitutions, and where we can accommodate the maximum of the substitutions, right? So if I start numbering here 1, 2, 3, 4, 5, 6, and 7, I can start from this side too. But what's wrong with that one is that though I am assigning the 2 number to the substitution, but this triple bond will get the higher number. So I have to keep it at the priority, and I have to keep it with the lowest number. So I will start numbering the chain from this side. So here at the 6 carbon, they are the 2 methyl groups. Now the third example is a little bit different, because now we have the more than one triple bond. So to name more than one double and the triple bond, we will use the terms di, tri. So then we can add it with the Y and E, or in case of the alkenes, we will write the diene or triene. But in case of the alkynes, we will use it diene or triene, right? So here, the name of this compound is, I have I have mentioned its open structure here. So here that is easier for you, but you should practice the line structures too, because this is quite convenient, and when we are doing the mechanism and more of your reactions, so this is quite easier to draw that rather to put all the hydrogens here, because this is understood that you are drawing the hydrogen here, right? So you know that there is the hydrogen with that carbon. So if we just go for this scenario, so this is 1, 2, 3, and at the third position there's the fourth group. I have mentioned all or numbered all of the carbons available, but this pattern is giving you that what kind of um, numbering pattern we have to follow for the naming of the organic compounds through the IUPAC rules. So here 1, 2, 3. At the third position, this is the methyl group. So this is 3 methyl, and this triple bond is between 1 and 2, and this will be the 1 for mentioning the position of the triple bond. Then this is a 4 carbon chain, so we are writing but, and YNE is for suffix for the alkynes. Now the another example is this one: 1, 2, 3, 4, 5, 6, 7, right? So this is the 7-member chain, and for this we will write hapt and YNE for mentioning that this is from the alkyne group, and the triple bond is between third and fourth carbon, so we will pick the first carbon and the lowest number, which is making the bond, triple bond with the other carbon. So this is 3 heptine. And now we will see that what are the substitution, what are their positions. So the substitutions are the same, the both are the methyl, but they are attached on the same carbon, right? So if the two substitutions are attached on the same carbon, so we do not write it separately, we will write it once, but its position will be mentioned 2 times. So to give that idea that this methyl is on the same carbon, this is not somewhere else on the fifth or the second carbon. Make sense? So this is a 6, 6 dimethyl 3 heptine. Now the third example is this one, and for this we know this is a 7 carbon chain, the longest chain, so we will write the hept and yn for the suffix, but there is the tricky thing, that is basically the 2 triple bonds. So for mentioning that there are the 2 triple bonds, so we will write diene, right? And mentioning their position in the molecule, so we will write 1 and 7, and we will repeat these positions, because if we are only writing the 1 or only writing the 6, so then it means that name is not correct, because here we are mentioning it as di, so there must be 2 triple bonds. So where is the second triple bond? So we have to mention its position. So this is a 1, 6 heptadiene. Now there is another interesting point, that we could have the compound which has this double bond, and at the same time it do have the triple bond. So how we will name that one? What would be our preference to choose as the numbering and as a parent name? So definitely the triple bond get the preference. So we will name that in a way, and we will start, but for the numbering, so that is a little tricky and a challenging thing, that we will treat it as an alkyne, because alkyne has a preference than the double bond, but we will start numbering from the side where there is the double bond, right? And we will assign the lowest number to the double bond and then to the triple bond. So in this case, if you just look at this one, this is 1, 2, 3, and 4. So I'm not going to that side, because I have to include the major functionalities into the longest chain. So this is the 1, 2, 3, 4. This is the 4 carbon chain, and this is the longest chain which I have selected. So I can highlight this one, so you may get this, that you don't get confused that which is the longest chain I have selected, right? So this is the longest chain which I have selected here. So now numbering, I will start from the side where I can assign the lowest number or the priority to the double bonding, right? So this is the 2, because this is at the second carbon where there is a methyl group. So this is the 2 methyl. This is the 4 carbon chain. So this is the bute. And now we have to mention the double bond position. So this is the 1 in, and there is the third and the fourth carbon between which there is the triple bond. So 3 1. And the second example is this one. This is a straight thing that we have to pick any of the longest chain, because these both methyl are the same. So you can pick any of the side. So if I'm choosing this as a longest chain, right? So from which side I should start numbering? Yes. So I will start numbering from this side. 1, 2, 3, 4, 5, 6, and 7. So this is the hapt, and the double bond is between the second and the third carbon. So we will write second and 2, and there is in, and the triple bond is between carbon 4 and 5. So this is the 4-1. So the name is 2-methyl hapt 2-ene 4-1, or you can write 2-methyl 2-haptene 4-1. And another thing you just have to notice that right now we are not writing it as ENE, because this is the name is not ending at E. So there is the YNE, right? This is the alkyne where we are, which is we are using as a suffix, and where the name will end. So the E will be with the YNE. So we will just remove the ending E from the in. Now this one is the 1, 2, 3, 4, 5, 6, and 7. So this is the hapt, and from which side I have to start numbering? Definitely from this side. This is the 1, this is the second and third, 4, 5, and 6, and 7. So the triple bond is between carbon 6 and 7, and the double bond is between carbon 1 and 2. So hapt 1 is for mentioning the double bond position, en, then 6 is for mentioning the position of the triple bond. So this is to mention the triple bond. So this is the 6th carbon, right? And this is the 7th carbon. So this is the 6-1. Now at the end, I have given the task, so which you have to attempt, and you have there are the 2 questions. So in the first question, you have to write the IUPAC name, as we have discussed the rules how we can name the alkynes. And the second question is that you have to write the name of each alkene which I have given. So you can just submit your this task on the Moodle. So I hope you get an idea. So if you have any queries, so just comment and discuss. So I would be happy to answer you. Have a good day. Take care. Bye-bye.